Okay, I'm using this worksheet where it says stoichiometry 1, moles to moles. So we're going to look at moles to mole ratio. So turn to the back. So the number 1, it says arsenic plus oxygen. So it's going through some sort of combustion to form arsenic trioxide. Okay, so you should have been able to do that, I hope, because this is nomenclature. Now, that's not balanced. That's not balanced at all. So the first thing you do with these problems is you have to balance them. So when you work it out, you should get 2, 3, and then 2. That is it balanced out. Okay, so these right here are your moles. The coefficients also can be used for moles. So it's asking me how many moles of arsenic trioxide will be produced with 3.4 moles of oxygen gas. So I'm going to write what they give me. Okay, and I know the ratios. So for every mole of oxygen, I have, so it's wanting me to find this arsenic trioxide. So for 2 moles of arsenic trioxide, I need 3 moles of oxygen. So that gets rid of the moles of oxygen. So all I'm left with is moles of arsenic trioxide. And so when I plug and check it in the calculator, so 3.4 times 2 divided by 3, I get 2.27. So that is my answer. Okay, so let's do another one. Okay, number 2, oops, sorry. Number 2, I'm just going to give you the, you'll have to balance it. But I'll give you the nomenclature. Well, plus hydrogen. Okay, so that's the equation for number 2. So, all right, and then the next one, number 3. So I'm giving you the equation. So because I'm not checking to see. I am checking to see if you can still balance, but I'm not going to check you on your nomenclature. That was a pain for y'all. So there's one. Okay, so when you can balance that one out. Number 4, I'm going to do. Let me get this to move up. Okay.
You're at the bottom.
No.
No, Mama. Do you need help?
No. Okay, number...
Move to the right. Move it to the right. No, Mom.
I'll get it.
Move it to the...
There we go. I'm just tired. All right, number 4. All right, so number 4, we have methane plus oxygen. Okay, so it produces water and carbon dioxide. So this is another combustion. So when you balance it out, oh, no, that's a 2. Okay, it's 1. So it's 1, 2, here. Make that neater. 1, 2, 1, 1, 2, 2, 1. Okay, so it's asking me if I have 8.9 moles of methane. Okay, it's one to know how many moles of water. Okay, I know I gotta get rid of the moles of methane. So for every mole of methane, because it's 1 right here, it needs 2 waters. So this cancels out, and I get 17.8 moles of water. So so essentially what it's saying is if I have 8.9 moles of methane, I'm going to end up with 17.8 moles of water. So, all right. So the next one, number 5, it's not balanced. You have Li2CO3 plus potassium iodide produces potassium carbonate plus lithium iodide. So that's the equation reaction. It's not balanced. And then number 6 is titanium plus water produces titanium 4 oxide plus hydrogen gas. Remember, hydrogen's a diatomic. So with this balanced equations, you should be able to do some moles. So now I'm going to go and to the worksheet that says stoichiometry worksheet and key. And I'm going to come down to number where it starts with 16. And let me get some more. Oops, I dropped that paper. Just a minute. Let me pick it up.
You saw my face.
Oh, that's fine. So I'm doing number 16 while Lily gets that all straightened. So I have 2. Oops, that's too wide. No. I need something because it's going to be a lot of writing. All right, so 2 butane. That's what you find in cigarette lighters. Plus 13 oxygens yields 8 carbon dioxide plus 10 waters. Okay, so that is my chemical reaction, and it is balanced. Okay, number 16 says how many grams of CO2. Okay, so we're looking for CO2. Now, before I even start, I'm going to find the molecular mass for all of these. And I'm going to use carbon is 12, hydrogen is 1, and oxygen is 16. So this one will be 58 grams per mole. Okay, this one will be 32 grams per mole. This one will be 44 grams per mole. And then water is 18 grams. Okay. And so I am rounding. Someone asked me today, we just don't have enough time. I just want you to get the concepts and get the simple math. I'm not fooling with significant figures for y'all. I just don't think we have the time for it. And I'm trying to get through this so that when you get to college, if you're taking it, you're not going to, you'll be familiar with it. All right, so 16 says, and they kind of help you out here. They've got the lines. All right, so if I start out with 100 grams of butane, and I want to end up with grams of carbon dioxide. That's my goal. All right, so the first thing I got to do is I've got to get rid of this. I've got to get rid of this grams right here. This right here, I gotta get rid of it. So I can do that because I know that 1 mole of butane is 58 grams, okay, of butane. That gets rid of the grams. Now I gotta get rid of the moles of the butane. And the way to do that, and I want carbon dioxide moles, is that in this balanced reaction, okay, I have 2 moles of butane for every 8 moles of carbon dioxide. Okay, this is the coefficient here. This is the coefficient for here. Okay, and this is the coefficient for here. Okay, so then I know I can use the CO2's 44 grams for every mole of CO2. The moles cancel out. So I'm left with what they want me to find, grams of CO2. So if I put it in my calculator, I got 303 grams of CO2. Okay, because 100 divided by 58, 8 divided by 2 is 4. So I went 100 divided by 58 times 4 times 44, and I got 303 grams of carbon dioxide. Okay, so now the dimensional analysis is getting even more fun. Number 17 says I got that same 100 grams of butane. Okay, and so I can use the same molecular mass. It's asking me how many grams of O2. So that's what I got to end up with. Okay, so I start with the grams of butane, and they want me to end up with grams of O2. Well, I have to go through the moles. Everything goes through the moles. Everything goes through the moles. So I can get rid of this grams here because I know that 58 grams of butane is 1 mole of butane. So this gets rid of this. Now I've got to get rid of the mole. Okay, I can do that because I can compare, I can get the ratio between oxygen and butane. So for every 2 moles of butane, I need 13 moles of oxygen. Okay. So this cancels this out. Now I'm left with moles, but I'm trying to get to grams. So I can use that molecular mass that I know. 32 grams is 1 mole of O2. So I can cross out the, I'm sorry, my son's playing some game, if you hear him. So this mole cancels out that mole, so I end up with 359 grams of O2. So if I start off with 100 grams of butane, I'm going to end up with 359 grams of O2. Now, number 18, we're still using that same reaction. So, says how many grams. So I'm going to go ahead and draw my lines. And usually it takes 4. I don't think I've given you one that takes more than the 4 areas. And once again, if you don't want to use these lines, you don't have to. Okay, so it wants me to find the grams of water. And it's saying that I have 5.38 grams of O2. Okay, so now I need to we're starting on a new problem. I need to get rid of the grams of O2. I know for every mole of O2 is 32 grams. Okay, so that cancels this out. So now I'm left with moles. Now, when I look at that equation, I know that 13 moles 13 moles of oxygen for every 10 moles of water. And do watch that chemistry tutor that I put on your Google Classroom. Watch that. That will help you too. I know that 1 mole of H2O is 18 grams. Okay, so the moles cancel out, and if I put it in the calculator right, I get 2.33 grams of water. Okay, so that is how, and it's kind of nice that in the beginning they'll start putting the very first one, they've got it written out for you. Okay, now I'm going to switch to the one that says stoichiometry mass to mass problems. So we're done moles to moles for the ratios. And now we're going to take that mole ratios and work on the grams, which is very similar to what we just did. All right, so, and all of these are balanced. So I am going to do number 4. It always helps if you push the right button. Okay, so number 4 is I have 2 silver nitrates plus barium chloride, and this is balanced. I've checked it. 2 silver chloride, and then plus barium nitrate. All right, so my coefficients here, this is like a 1, 2, this is like a 1. Okay, so those are my moles. Now, the next thing I do is I'm going to figure out the molecular mass. And so I'm using Ag is 108. Barium is 137. Whoops, what happened?
No.
What? Help!
Help, I'm falling in. I can't get up.
I can't get up. Hurry up. Well,
This never happened before. So, oh, you fell.
a what?
You fell over. The camera fell over. It needs more help than we do.
There we go. Alright, so we got it fixed.
You
So, Lily-
little jerk.
So,
He
Lily.
stole my cookie.
So let me make this a little bigger.
Patrick, go away.
I don't know what you're talking.
He's trying to eat a cookie, guys. You know that's all on video. He's, God help us. Alright, so
can't
the
wait until he
barium
leaves.
is 137.
Mama, it's gonna be way bigger than the rest of that equation.
Yeah, I know. And let's see, nitrogen is
close the number.
14. That's okay. I'm gonna don't really need it. And chlorine is 35. And yes, I am rounding up because I'm not gonna worry about sig figs. And O is 16. All right, so here, let me see something. All right, I'm just gonna get rid of it. All right, so I'm going to. Let's see here. We're going to rewrite it as, where's my barium? 2 silver nitrate plus barium chloride gives me silver chloride, and I need 2 of those, and barium nitrate. All right, so here the molecular mass is 170 grams per mole. This one is 207 grams per mole. That's this one. This one is 143 grams per mole. And then barium is 261 grams per mole. Now, I may not need all of those, but I've got them there in case I do. So, the first question says I have 5 grams of silver nitrate. Okay, and I'm trying to get to grams of silver chloride. So I know that 1 mole of silver nitrate, and it is 170 grams. That's the molecular mass. So this gets rid of grams. And then I know for every 2 moles of silver nitrate, I need 2 moles of silver chloride. Okay, that gets rid of the moles of the silver nitrate. So 1 mole of silver chloride is 143 grams. So when I plug that in, I get 4.21 silver chloride. Okay. All right. So let's see here. Make it a little bit bigger. There we go. Not that big. All right. So if I'm doing number 5 on here.
Please erase that.
Okay. If I'm doing number 5, it's still coming. It's not going to. All right. So if I'm doing number 5, okay, I have 5 grams of silver nitrate again. And it's wanting me to get 2 grams of barium chloride. So I know this is going to be 1 mole of barium chloride. And I've already done the calculations, so I know what it is. So it's 207 grams. But let's get rid of the grams of silver nitrate first. So that's 170 grams equals 1 mole. That's the molecular mass. So that gets rid of this, and this is silver nitrate. Okay. I know for every 2 moles of silver nitrate, there is 1 mole of barium chloride. And so then I've already done this part, so that gets that, and I plug it in the calculator, I get 3.04 grams of barium chloride. Okay, so hopefully with me working some of these problems out, that's going to help you. But also look on there, I have a CK12 video, and the chemistry tutor will help also. So if you have any questions, bring them to me at the 2 p.m. Zoom meeting, and I have put those instructions in Google Classroom also. So see you tomorrow at 2.